All right. We are live, but I've muted. Cool. God, so I started doing this when I got really bored, like June, yeah, about a year and a half ago. So like June 2020, I got super bored and just decided to do it then. I started just doing like a Python course on YouTube, and then I switched over when I discovered that YouTube started taking down some of my content when I started talking about security. Mm-hmm. All right, this Hyper-V VM is not playing ball, so let me see if I can at least fire up the Kali machine as a backup, just in case. Can everybody hear us? Hopefully.
Hello.
Let me bring up your microphone a little bit. All right. Ginger, can you give me one more sound check?
Hey, how's everyone doing tonight?
There we go. Perfect. All right. Well, welcome, friends, to Attack on Tuesday. My name is Taggart, and I'm so excited. We have a very special session tonight. Joining us is Ginger Root, who is an expert in Pwning boxes, basically. So we're going to talk a little bit about binary exploitation, specifically Windows binary exploitation and reverse engineering to make that exploitation possible. We're going to start by taking a look at the brain pan room in TryHackMe, and then we'll move on from there. But that's where we're going to start. So, Ginger, welcome. Anything you want to tell us about yourself?
Uh, check out my Twitch channel. I'm not. I don't have a lot of social media stuff, so.
Yeah, let's get that shout out going. Yeah, check out Ginger's new Twitch channel. Definitely got the skills. Um, and this is pretty exciting. So, and this will not be the last time we do a guest session here on this stream. But no, don't sell yourself short. How long have you been doing cybersecurity?
Uh, so professionally for about 4 years now, and I've spent most of that time working on offensive skills, but always in sort of a blue team environment.
That's great. And what got you interested in infosec?
I left culinary in 2016, and then I, s- I started trying to get into development, and then I was talking to someone who'd been in sort of IT industry for a lot of years, and they told me to look at security. So I got into security, starting out with the basics, and then I did a couple CTFs, and I really, really enjoyed that, and I just kind of kept hacking stuff ever since then.
Very cool. All right, so let's go after BrainPan here. Looks like we have an IP address and not much else. So what's the first thing that we should take a look at here?
Well, you're gonna want to deploy the machine.
It is deployed.
Oh, okay, yep. So let's. So right now it's still gonna be sort of like a normal CTF. So
Mm-hmm.
let's go do our normal stuff. So we're gonna, run an Nmap scan and see what we're dealing with first, or
Ready?
whichever.
Yep. So the flavor here is that I like to run it against RustScan first,
Yeah.
um, just because it's fast. It's a quick hit on TCP ports, and then after that, it'll run a full Nmap enumeration on anything that it finds.
More like slow map. Yeah.
All right, so it looks like we have something on 10,000. That sounds like webmin to me, but maybe not. And then something on 9999. Interesting that those are the first ones that we found here.
Yeah, those are. I think they're both gonna be custom for this app for this box.
Okay, cool. Let me just netcat that first port to see if there's anything interesting there. No. Oh, okay. Looks like yes. So we've got HTTP something or other running on port 10,000
Yep.
and 9999. Oh, it looks like we have a specific terminal app running there. Cool.
Yeah. So that's an application listening for network connection that's going to accept input.
All right, cool. So am I going to want to go after this web application here?
Yeah, so I would start doing your normal stuff for the web application,
All right.
and then we'll move into the binary exploitation
Love it. All right.
stuff once we find it.
Web is definitely my happy place. Before I moved into cyber, I was doing stuff for education, but really what that ended up translating into was I was writing web applications to be used by schools, um, which turned out to be really handy when you went to go try to exploit the web applications that were building prior.
Yeah, web is definitely a weaker point for me. I know all the tools and I know all of the skills needed and stuff like that, but if I had to manually write SQL injections, it
Oh,
might
I
take a
mean
little while.
that sucks even if you know how to do it well.
Yeah.
Yes, I do want to persist my session. We will call it Brain Pan. There's all my stuff from the Deadwood CTF. That should be in THM, but that's fine for now. Okay, so yeah, sure. Update your plugins. And then what I like to do is I use a I use a separate profile in Brave that
Hmm.
is configured to speak to uh, my proxy, right? And so all the other tools that I want, all the browser extensions that I care about for web app pen testing, I have in this specific Brave profile, right? Like hack tools that has all my shortcuts for reverse shells, things like that, Wappleizer, and I have that nice and isolated here. It's pretty handy
Yeah, that's pretty slick.
rather than having to worry about it here or doing it in incognito window. All right, so we're looking at port 10,000 for the web app. Or are we? Yes, we are. I just forgot to write 10,000 as I was saying it. Okay, and Zap is catching it. Yes, I use Zap instead of Burp.
Oh yeah, same actually.
Oh, really?
Well, I use both, but Zap's free.
Yeah, exactly.
Yeah,
It's free and I mean, I actually think there are a lot of things about the way Zap presents information once you get used to it, right? Every application has its
yeah,
idiosyncrasies, but once you get used to it, um, I find it a little bit saner than Burp. Certainly fewer windows.
yeah. Like I really appreciate the like the scanning capabilities of Zap for free. Uh, but there are times when I will use Burp just for Intruder.
Oh, totally. That's understood. I have wrangled the fuzzer in Zap to do what I wanted to do, but it wasn't, a super intuitive process. So this is just
Yeah,
one big old image. Let's
it is. Yep.
view source. Nothing interesting there. All right, let's move over to brute force enumeration. So fire up Ferox Buster, and yeah, we'll start with actually big.txt. There's like three lists that I use in succession. The first, and
Hmm.
they're all from sec lists, right? There's discovery, web content, and then there's big.txt, which actually isn't all that big. And then there's like the directory lists, and there's small, medium, and big. And so from big.txt, I'll move over to the medium if I can't find anything.
Yeah, I kind of do the same thing. I start with common, but yeah.
Oh yeah, yeah. Uh, let's take a look at Wappleizer though, see if we got anything. Okay, ooh. Okay, so it's Python 273 we're getting back as the programming language, which is always interesting. One of the things, if I see that happen, is I'll go check the server. It's simple HTTP. If it had said something like Verkzoid, right, as a Flask app, I might have gone and checked for a console or something like that.
Oh yeah, that was
I think that was a Hack the Box room or something like that.
yeah.
Did
I was
that.
like I've done that before, and I don't remember what it was exactly what it was for.
Later versions now of Flask require you to set up a pin for the console if you're going to deploy it. And if you brute force the pin, it bricks itself and requires you to manually restart the application.
Is that just like an attempts or thing
Yeah,
or gotcha. So 000 is probably not a great pin.
I mean probably not. Forgot I need to give this thing so much extra space when I'm zoomed in. Nope, still not enough. That's better. Wait, I'm I'm fuzzing the wrong app. That was the URL from the Deadwood CTF, which apparently is still up and not giving me.
Yeah, it didn't seem to be giving you any issues.
Oh, let's try that again. There we go.
Yeah, I'm not. I'm still using Go Buster, so I haven't used Ferox Buster yet.
Ooh, slash bin. Interesting. What is @/bin? Love it. Okay, there's brainpan.exe.
Yeah, now's where the fun begins.
Interesting. Okay. Let's move this here. Cool. Brainpan.exe. And I will, because I am suspicious of my Flare VM, I will copy this exe. I'll copy it to the host. We'll start it there. And if we need to, we can fire it up elsewhere as well. But I should be able, with the debugger and a little bit of WSL magic, I should be able to do everything I was going to do in the VM.
Yeah.
All right, cool. Then, all right, so we have this exe. So what's the first thing that you would do with this executable once you caught it?
So I'm assuming that it's in a lab and I don't have to actually check it or still
Right.
or that. I would just run it, see what it does. Uh, we're downloading it from the Try Hack Me machine, and we know there's an application accepting 9. So if this is the application, we would expect to see that application listing on that, which would be ideal because then all of a sudden we have a lab environment for looking for vulnerabilities in that application.
Makes sense. A couple of other things from a blue team standpoint that I might do if I were looking at this as from like a malware analysis perspective. Um, and actually, even for this, I might fire this up in a disassembler just to see what it looks like. So I really like Cutter, and so I might check this out in Cutter just to see what it looks like.
Mhm.
And one of the things that's nice about Cutter is that for the decompiler, it does use the Ghidra decompiler. So you have like the nice Ghidra stuff when you want it
Oh, gotcha.
without it. But if you want to look at the assembly, you can still do that as well. So a couple of things jump out to me right away. The first is I see some calls to MingW based functions, meaning that this was a Linux binary, or it was compiled on Linux for
Yeah.
Windows. Um, which they told us in the lab, but now we know it from some of this other evidence. Um, so we're in the main. Here's the main function here. We see a
Hmm.
lot of strings. Welcome to BrainPan. Let me zoom that in just a little bit so it's easier to see. We have access granted. We have sockets getting set up, and then we might want to see if there's a port that's configured for that. Um, Somewhere. Hey, it's Zarsek. We're working on BrainPan. Some more prints. Printf. So it might be something to look at, right, to see if there's a format string, something or other. And then here's just the string breakdown, which can be useful just to see what we're looking at. All right, cool. And this is Cutter for those who just got in. And you can get Cutter at cutter.re.
Yeah. It's a pretty awesome tool.
And all right, so let's fire this thing up. And do we want to fire it up straight or what's the deal?
Yeah, we can fire it up straight because if it's something that we actually want to deal with, we can just attach with a debugger.
Okay, cool. Because I still have less than 100% faith in my Flare V. Oh no, it is up. Great. The Flare VM appears to be up and running, and I want to do this. I want to practice safe binary analysis, so I will move this thing into my lab machine before I fire it off.
Yeah, absolutely. Whenever you get an executable from the internet, always put it in a VM.
So Sarsek asked, Cutter is an R2 front end. So it used to be, And then something kind of politically weird happened in that development community, and Cutter's developers and some of the R2 developers split off and made a separate decompiler called Ryzen, and that is now what backs Cutter. Um, so Ryzen is actually the latest and greatest version of R2. Now I use R2 because it's easier to install in a lot of ways, but Ryzen is actually the new hotness, especially for the command line. But Cutter uses Ryzen in the backend.
Gotcha. I didn't actually know that.
Yeah, it was like basically the R2 developers like being regressive jerks, and they had like offensive jokes in the documentation. People like, hey, we don't feel great about this community, could you stop that? And they were like, no, shut up. And so the developers split.
Ah, gotcha.
So I respect them for actually taking a walk and doing their own thing.
Yeah, no, that's pretty cool.
Okay, so immunity is installed. Let me move the brainpan.exe over into our lab machine. All right, brainpan.exe, and presumably this is a console application, so run it through PowerShell or something.
Yeah.
Okay.
I mean, it's theoretically going to wait for input, so you can just double click it, but
Oh,
however
okay.
you want to do it.
Yeah. Okay. So it gives us our print server socket created, bind done on port 9999, waiting for connection. Uh,
Awesome.
okay, cool. So then,
Yeah, so now we want to hop out to a different machine or connect to it from this machine on localhost or something like that and start looking at things we can do to this application.
got it. Okay. Let's see if I can
Uh,
do that. I should. This thing has
and
WSL in it, so that'd be fun.
yeah, you should be all right. And we should fire up immunity and attach it just so we can restart it pretty quickly and all that stuff.
All
Fun
right, so
stuff.
so let's talk through what that means. We're gonna fire up the immunity debugger. What does attaching mean?
So it's going to take a process that's running and then it's going to put it in the debugger and then allow you to manipulate it, view what's happening in the CPU, stuff like that.
Got it. All right. So attach, and looks like our options are slim.
Yeah.
So we'll attach there. All right, cool. This is going to be very small for people, so I may break out my magnifier at some point.
Yeah, that's probably a good idea. So when you first attach it, you're probably going to see in the bottom right hand corner it says paused. The
Yes, it
the
does.
yeah, the F9 key is going to be your hotkey to
Pause
continue
and
or
unpause.
run.
Okay. And so for since this is like the beginning of this, right? And we want to talk people through what are we looking at here? We're seeing a lot of hex. We're seeing some opcodes. What are we getting shown in immunity?
Yeah, so the top left hand corner is going to be sort of those are the instructions that where the CPU is at currently. So right now we're looking. I think it's a bunch of int3s, so we're looking at some breakpoints. On the right hand side, that's going to be register information. Right hand top side,
Mm-hmm.
that's registers, and that's important for the exploit that we're doing. And the bottom right hand side, that's going to be like your stack.
Okay.
So for those unfamiliar with the stack, it's I always get this backwards. Last in, first out.
Yes.
Yeah, I always say that backwards. But basically, it's like a stack of plates for data. So
Exactly.
you, you
Yeah.
you put a bunch of data on there, and whatever you put on last, you're gonna take off first. So that's where you know, not to spoil things, but we're gonna be using the stack.
Right. So basically, in a little bit more detail, just to build this out, right? So like, oh, thank you, Husky. I can make it. Oh, appearance, font, font 7. That is slightly better. OEM fix is the biggest. Thank you, Husky. Love it. Oh man.
Oh yeah.
I'm 10 years old again. Okay, cool. So yeah, so the stack is, I think when people, including myself, start learning, you know, reverse engineering, binary exploitation, the stack is one of the most troubling concepts to get your head around. I mean, in and above understanding what assembly opcodes are saying, like the way that the stack works, it works exactly opposite the way that humans think about doing things, right?
Yeah, it's a it's a bit of a brain breaker at first. So it would be like a point in memory, and it's going to grow up when you put stuff on the stack. So it when you start working with more advanced exploits and stuff like that, that's a good thing to keep in mind because you never want the stack to grow up into area of execution and just blow stuff up.
Yeah.
So getting comfortable with using the stack and how the stack works, it's it just takes a lot of practice.
So, like, roughly to break that down just a little bit more, for my own edification as well as everybody else's, like, if you think of a program as a continuous slice of memory, right? Up at the top, you have kind of like the preamble stuff that you're going to need to run your program, any of the imports that you have in there. Then you have your program code itself, right? And then, like, way later in the space that makes up your program, um, is where the stack begins. And it's so far down to make room for whatever the program might need. But here's the part that's strange: the instructions up at the top in the code here are going to more or less run from top to bottom. However, the stuff that is going to get stored, things that functions use as you move through the program and call different functions, that memory space that's used to keep track of things is going to begin storing stuff at the higher addresses toward that bottom of that slice and move up to higher addresses, which is why the stack of plates metaphor is so good, because the program is going to put stuff onto the stack of plates, and then as soon as it's done with whatever it used, it's going to take those back off again, moving us back down to higher addresses in memory. Sound about right?
Yeah, it's a way better explanation than I gave. Thank you.
No, no worries. I want to be explicit about stuff, not only because I'm still learning a lot of this and I want to make sure that I don't have any misconceptions, but also this stuff is really freaking hard. And
Yeah.
uh, demystifying it as much as possible is what we want to try to do. So, okay, so we have this thing loaded up, it's paused, and we want to do what now?
So we're going to press F9 just to continue
Okay.
execution and let the program do what it wants. And then we're going to connect to it from somewhere else and see what we can do to it. Because we'll be able to see what's happening to the application in the debugger.
Okay. Looks like I don't have WSL, but that's fine. We'll open up another PowerShell window, and there's no way I don't have Netcat on here.
Yeah, you should.
And if it's not in the path, Claire has Netcat built in. That's what I thought, Husky.
Yeah.
And yet, I mean, like, I know it's here. It's just that the pathing is probably weird. So let's go find it. Oh, is it NCAT? Thank you, Professor Emeritus Husky Hacks, helping us out here. Okay, so NCAT is here, and we're gonna just do 127.0.0.1 9999. All right, there we go. So we're connected to the BrainPan server locally here.
Sweet. So we can just throw a string at it and see what happens. That would be the first thing that I would do is just take
All
a
right,
peek.
toss it a bunch of A's. Access denied.
Cool. So it's probably some sort of password functionality. So from here you could do one of two things. Like you could go do like an object dump and try and find the functionality that's receiving the password. Look at, disassembled code and look for buffer overflows that way. We're kind of at a benefit. TryHackMe's already told us that there's one, so we can just start throwing A's, a lot of A's at it.
Incredible. I know that we have Python in here. I don't know why it's being a weird being weird about it. I know for sure we have it. That's okay. I'll fire.
Like
I'll,
if you ever want to try something that's a little bit more like look at the code
Mhm.
style, Vuln server is what I would recommend.
That's cool.
Because you can use a fuzzer, but all the source code for the application is there, so you can actually go find all of the things you'll need to create an exploit without ever hitting it with a fuzzer.
That's cool. And yes, Husky, you're absolutely right. We have Python.exe. You can tell how little time I actually spend. Even though I use Windows all day, you can tell how little time I actually spend in a Windows development environment. Because
Oh yeah,
like
man.
none of this stuff. The
Yeah,
only time I use PowerShell is to get out of PowerShell.
yeah. Like I go to work and I boot up VMware, and I see Windows at the end of the day.
All right. So okay. Um, so we can start writing some Python if we want, or we can just start tossing A's at it, just
Yeah,
to see. So let's do that. Do
yeah.
a
Let's.
very naive version of this. Okay, access denied, and
Everything's still running fine.
everything's still running. And
Let's try and send like 1,000 at it and see what
yeah,
happens.
so for this, I actually am going to go back over to my own WSL and fire up my friend, Interactive Python, and just so I can do that. Okay, get rid of that, and now we'll fire this up one more time. Give it 1,000 A's. Access
Okay.
denied.
So we didn't see a crash. Let's try 2,000. So this is
2,000.
yeah, this is kind of the iterative approach. You're basically just gonna keep shoving bytes into this application and see if it breaks.
Mm-hmm. Now, it's interesting. It didn't let me paste anymore. At least I can't see it.
Hmm. Can you just echo into endcat?
Oh, wild. Um, so
Or just do like
I wonder if it's because yeah, there we go.
yeah.
Echo's not gonna. There we go.
Hey, there we go.
We broke it.
Yay! So this is the key part you're gonna look at. So we want to go over to our debugger and look in the top right section
Okay.
because we want to see how it broke because that's going to tell us how we can exploit this or if we can. Yeah, there's some vulgarity. Sorry about that.
It happens.
Yeah. Uh, so we can see that there's a couple things. Well, we can see a bunch of these, which is great. That's what you want to see. But we can see 41, 41, 41 EIP, and that's really important because EIP is the extended instruction pointer, and that's going to tell the application, that's the memory address for the next instruction that's going to be uh, performed by the CPU.
Mhm.
So if we can control that, we can tell where the CPU uh, to find its next instruction at. So that's really important. And also ESP, if you look at that, that memory address, it looks like it has a bunch of A's in it. And if we go back down to the bottom right hand corner, that memory address will be the one on the top. And we see we have
Yes.
a bunch of A's. So that's also important. That means we've written to the stack. So if we have control of the execution of the program and we know where we can write code to, theoretically we should be able to jump somehow to that code and execute it right off the stack.
So one metaphor I've been working on for this, just to help folks understand. Actually, before we even get there, let's back up quickly. We're talking about ESP, EIP, and these are registers. But what are registers?
Okay, so a register is like a little spot in where data is stored that allows the application to know and do certain things. So the EIP is 4 bytes in memory, and that's the application is going to know to look there to know to find its next instruction. Or ESP is the pointer to the top of the stack, so the application knows to look there. The next piece of data on the stack.
Yep. Right. So, one thing that really helped me, again, this is one of the things that's cool about doing this kind of work is that you are at the level of the bare metal, right? And so when we're looking at these things called registers, these registers are part of the architecture, the literal physical architecture of the CPU, right? Um, Now, the EAX, the E is important because that tells us a little bit about the fact that we're using a 32-bit architecture. It tells us how many bytes we're talking about, um,
Yeah.
right? And each of these two letters here is going to represent a byte for us in terms of how many addresses there are, or yeah, how many bytes there are in the register. But um, these registers, think of them as really really quick storage slots, right? And
Yeah.
they're the fastest possible piece of memory, but they're only this big, right? That's why they're so fast, and they're like physically part of the CPU rather than going out to RAM or to a local cache or something like that. It is right there on the silicon for the CPU, and things are moved in and out of there very very rapidly to keep track of what the CPU is doing. And so some of the ones that Ginger was talking about, the instruction pointer, right, is think of it almost like the playhead of God. I'm feeling old, but like the playhead of a VCR, right?
Yeah.
Or if you do any audio editing or video editing, the playhead as you see it go through the video. It's keeping track of where it is and what it's doing at that moment. And so that EIP is constantly changing. And then the stack pointer, right, is and the base pointer define the range of the current stack frame. And those are going to be changing as the program calls different functions and moves things on and off the stack and changes up its size. Yes, the GUAR, the VCR is like a DVD or a laser disc if you're cool enough to remember laser discs. But one of the crazy things that you can do right now that we know that we're able to mess with the instruction pointer, right? Imagine editing a video to make the actors in the video say whatever you wanted just by cutting together pieces of what's going on. That's ROP. That's like my metaphor for ROP. But you can make this program go wherever you want, including, since we can fill this up with our own bytes, fill it up with whatever we want and make the program go there. Husky asks, with quite the leading question, because I paid him to do this in advance. What's a stack frame? Ginger, you want to take this one?
So the stack frame, well, to be perfectly honest, I don't know in an academic sense what it is, but it's you know, everything in the stack. It's going to be your everything in between your base pointer and your everything between EBP and ESP.
So yes, and I'm gonna take a quick diversion on this, just because I think there are a few things that you start when you start looking at disassembly, you'll start seeing a bunch of stuff all the time, and you're like, what's going on with that? Okay, this is what I wanted to talk about in terms of stack frames. Every function except for main, because main is a special snowflake when it comes to this stuff. But no, actually, sorry. Main in the case of a Windows program is going to do this too. Um, every every function is going to have this kind of series of instructions, and you're always going to see it as like the preamble to the function. And I think it's so cool once you know to look for it, what you're seeing. So the first thing that you're seeing is that we push, meaning we add something, we put a plate on the stack. And the first thing that we put on the stack is the base pointer, meaning the current base pointer before we do anything else with the stack. We um, add that to our stack currently, because that's going to be where we return to when we're done. or no, sorry, that's not right. But we push the current address of the top of the stack there. Then we move the the stack pointer to the base pointer. So we change what was the stack pointer now to the new base pointer. So it's like moving it up here. It's almost like leapfrogging. Then we subtract a certain amount of value from the stack pointer that was, which means we move the stack pointer up. And this process creates a new stack frame for the function that is using it. So this whole thing creates a new stack and then creates space for the stack. And
Yeah,
then that function is going to use that space for its variables or anything else that it needs in there. So that's what a stack frame is. And then let's go to maybe a smaller function. uh,
yeah. I was gonna say that's actually something you might end up doing manually in more advanced exploits.
yeah.
Uh,
And then once you hit the return call on a function, it basically says, "Oh, okay, done. We're going to remove the rest of that stack. We're going to kind of reverse that process and go back to our previous base pointer, right?" And this is going to happen for literally every function that you see in disassembly. So when you're thinking about the stack, you're thinking about this kind of series of rearrangements of stack pointers and base pointers to make space for each one. Um, and in fact, we've already seen something that makes that important. Limo, thank you so much for the follow. Because one of the things that we've seen here is that we've been able to mess with this instruction pointer. Um, it is also entirely possible. What did I do? There we go. It's entirely possible that we're also able to, we overrode the base pointer right here.
mhm.
Now, some of that has to do with the way this program is built, but also if we're able to control the base pointer, you can imagine that there's a certain amount of space that we have to work with. Um, I'm not doing a great job explaining this. Let me try one more time. We were able to overflow part of the stack here. And in fact, we were able to overflow so much of the stack that the pointers that control the size of the stack got compromised. That gives us a lot of power over this particular program. And I'll stop there.
Yeah, it's at this point it's pretty much just writing the code. We know without any if there's no other defenses on the system that we can absolutely own this application.
Yep.
One second. Sorry. The Guire, you were talking about what's the least significant bit. I read as A1, A2, A3, A4, but I've read it as A3, A2. So yeah, that is endianness.
Mm-hmm.
And what we're going to come up against that actually when we get further on in the exploit.
Okay, cool. So let's see. We we
Oh
have
yeah,
we have an overflow of the instruction pointer. It's all A's, so we don't know exactly how many bytes we need to toss at it to overflow. Um,
yeah. So the next part is going to be finding out where in our A's EIP is in. So there is a tool in the Metasploit framework, like a chip with framework, to do just that. Um, I'm not sure exactly where you have it installed, so I'm not sure how it's set up. But in your Metasploit directory, probably in Calix would be like I think it's user or USR share Metasploit
with framework
uh, tools exploit. Yeah, so pattern
pattern
create.
create, yeah. And would we just give it the length of the pattern we want?
Yeah, dash L, and then anything we did. I think you threw
I think it was somewhere
two.
between 1,000 and 2,000. So say
Yeah, I mean
2,000.
we can go crazy with it.
All right, cool. And that gives us. Do you happen to know? It's totally escaping my brain. Like the name for this kind of sequence. There's a mathematical term for it. Sorry, you
I
might
want to
know
say
it.
cyclic.
It's well, so it's cyclic, but it's like named after a mathematician sort of
Yeah,
series.
I know.
It's gonna drive me
Cyclical.
crazy.
Yeah, I don't know.
So this
To be,
is go ahead.
I just say to be perfectly honest, I've used this, and then I've gone and used like lyrics from songs before. It just
Incredible.
you can use basically anything.
Oh man, this is gonna drive me crazy. Husky Tsar, if one of you feels brave and wants to research what the name of this, it's there's a mathematical term for this kind of sequence, and the sequence type, what defines it, is that for discrete lengths, no arbitrary length of the sequence is repeated anywhere in the sequence. That's what makes it special and why it works for this. Um, so pattern create is one way to do it. There's another tool that I use frequently for this, which is in Pwn tools. So if I import into my interactive Python, um, I have just like a cyclic function. There's also a command line version of it, but I can also do cyclic 2000, right? And it gives me the same thing. It gives me this sequence um, where no subset of the sequence repeats anywhere inside of it.
Gotcha.
Yeah. And so what's nice about cyclic, and we'll kind of play it with both of these, but what's nice about cyclic is that there's also a symmetrical cyclic find, and you hand it the bytes that got overflowed, and it'll just give you the number back of how many where the overflow is.
Oh, okay, yeah. The pattern create has a binary next to it called pattern offset that does kind of the same thing. I've
Yeah.
never actually used Bone Tools to be perfectly honest.
Oh man.
I
It,
know
it's no, it means you're
still living in
better
the
at
Stone
this.
Age.
Really, is what that means.
I do everything manually,
That's
which
so good.
not great for time, but
No, it's really important to for understanding though. Um, Pwn tools, I started using it to kind of get away from for things like shellcode creation, right? Um,
yeah.
I didn't want to have to do that, and so I use the stuff built into Pwn tools. But then, um, actually going back and learning how to do a lot of that stuff manually, super valuable.
Oh yeah.
All right,
So let's pop that in and see what we get in EIP. Oh, so right now it is going to be paused because
we killed it.
uh, you killed it. Yeah. So Control F2 is in the debugger. Restart it.
Control F2, got it. Okay, and
And you
and
might hit a couple
F9 to run it.
breakpoints. Yep. You might have to hit it twice. I think. No,
Looks
you're
like
good.
we're off to the races. It's running now. Okay, well, okay, so we're gonna echo our cyclic series to and okay, it died, but it died with what? And this is the part nice. So it
Yep.
died with a different value in the instruction pointer. 666. Very nice.
Yeah.
Uh
It's gonna be one of those days, eh?
oh yeah. This isn't we're not even in October for the Halloween episode. I got to figure out something to do for that 66616167. Um and so my usual process for that is then just to take that over to cyclic find, same situation, and give it in hex 0x66. God, what was it? I can't remember things.
Yeah, man.
I want to be a nitty
This
gritty.
I always go back and forth about 3 or 4 times when I'm doing this part.
Can you copy values? Yes.
Yes, you
Woo.
can.
That makes it more convenient. Hell yeah. Okay. 66616167. So 524 is our overflow, meaning that 524 bytes is what the buffer can take. After that, we're starting to overflow stuff like the instruction pointer.
Yeah, specifically what we found is the amount of A's before EIP.
Mm-hmm.
So if we do like 524 A's or B's, C's, what we should see is a bunch of A's that happen. EIP will be B's, so it'll be you'll see 42s in there, and then everything on the stack will be C's, and that's
And
hopefully what we
let's
find.
let's prove it.
Yeah,
So what we'll do now is we'll do print A times 524 plus B times, we'll just do 4Bs, right?
yeah,
And quick note, okay, remember that before actually I do that, well, we'll do it, but remember, if you're thinking, wait a second, this is not the same size as this, remember that when this B gets encoded as a value, it will take up two place values in hexadecimal. Um,
yeah.
so if we think, what is it, ord um, B, ord gives us the decimal, or no, does it give us the hex value? No, it doesn't. It doesn't. That just is a coincidence. Ord gives us the decimal value of the ASCII code. Right. If we want to see it in hex, there it is, 42.
Yeah.
Scissor, thank you for the follow. Um, and so this is in fact, if we were to say B, 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 oh, just kidding. Um, that was dumb. If we wanted to see, I'll do it this way, hex ord B for C in, wow, oh, long day for C in 1, 2, 3, 4. So what we're looking at is 1 4 2 4 2 4 2 4 2. So 2 4 6 8 2 4 6 8. So these are in fact the same size.
Yeah, I would. Uh, Everyone who ever starts this, I strongly recommend find an ASCII chart that they don't
Yes.
mind looking at and download it.
Yeah, I mean, honestly, the reason why in most of these demos you see people doing it with a bunch of A's is because we've all memorized 41, so we know how to see it.
Yeah.
But yeah, no, that's a great call out. If you go check out, let's see, I think, how many times have I Googled ASCII chart? And the first one that comes up is never good. Was the rapid tables one always comes up first. It's like it's fine, but you know, you want to get used to seeing some of these. Another one that a lot of folks know without knowing that they know it is 20, right? Because we're used to seeing %20 as a space in URLs. But yeah, you want to get used to seeing both the decimal and the hex encoded values for ASCII, because they're going to come up quite frequently in this particular discipline. Okay, so we have, in theory, um, we've copied over the overflow that has our B's. So
Mhm.
what we're trying to prove here is if our overflow is correct, that we're overflowing the buffer that's asking for our password with 524 A's. If we've gotten it right, then the instruction pointer, which is next to that in the stack, right? If we think about the way the stack is laid out right now, what we've kind of learned is that we have a buffer to accept input from the user getting that password. And it's 524 bytes, we think. We're going to fill that up, keep going because the function that is reading that input isn't safe. And we're going to overflow it with 4Bs to put into the instruction pointer, meaning that our instruction pointer, if we've done everything correctly, should look like 42424242.
Before you do that, we should also the padding at the end because we know that 2,000 bytes overflowed it, and we're about to send 528 bytes, so it might still work, but it's always safest to keep once you have a length that works, just try to keep your payloads the same length.
Oh, interesting. Say more about that.
Yeah. So like currently we're sending 528 bytes. When we send 1,000 bytes, it didn't crash, so this might not correctly work.
Oh, right.
So we're going to want to make sure that we send 2,000 bytes. So we would do like print A times 524 plus 4Bs plus C times 2,000 this length of whatever.
Right. Okay, I like that. Okay, so we know that's 24 plus 4b's, and we're going to do payload plus equals c's times 2000 minus the length of the payload.
Yeah.
Love it. Okay, so we have our payload that is the same size. It's a good call. And go back over to our listener here. And yes, our BrainPan XE is running. We will get rid of this. By the way, I had to learn this the hard way. I'm so used to using Control W to get rid of the last word on the Linux command line. Control backspace does the same thing in PowerShell. That
Well,
isn't right.
I learned a thing today.
I got so tired of just uh deleting large commands. I was like, there's got to be a
Yeah.
way to do this.
It's usually around this point that I start developing like a Python file to work with.
Right, exactly. Okay, so we've got our payload. 524 A's, 4 B's, and 2000 minus 528 C's. Okay, we've killed BrainPan once more, and
Perfect.
indeed, our instruction pointer has been overflowed correctly, and we got the B's in the instruction pointer, so we know we've got it right there. Nice. All right, so we can overflow the instruction pointer. What now?
Well, so now we need to figure out how to move from EIP to some sort of instruction because we know EIP is only so it's going to point to something that already exists. So it has to be an instruction which will bring us to our execution point, which we want to execute on the stack. So there's a jump command in assembly. Maybe we should bring that up because I don't want to just say it out right out. But if we go look at the command in, I think we
I should have left Cutter open. Let me bring it back up. Yeah, yeah.
yeah
How many tools can we possibly bring to bear on this one executable? Um,
yeah you could probably hit Control F in the debugger too.
right. So a jump. Here's a good one right here. Let's jumping to ECX.
Yeah.
Um, oh, love it. Here's a bunch of jumps right here, and actually a couple of three really good examples of jumps. Um, so we have a jump here, which is a straight up move to a specific memory address. So when this instruction begins to get executed, what's going to happen is that the assembly is going to, this is control flow, right? And Cutter gives us these nice arrows. It's going to go all the way down to that address, which, of course, I couldn't remember what it said. Um, right there, there's the end of that arrow. So that's one kind of jump command. We also have g1ng, which is a jump if not equal. So this is when you see those, you're looking at conditional statements, right? Okay. Was there a specific jump you wanted to take a look at, or just the idea of
Uh,
jumps?
well, actually, I was gonna say like you can generally like assembly is pretty well documented. So if we wanted to go look at different jumps here, one second, is it or like examples of stuff? Like if you're ever not sure about what you're doing, uh, there's pretty good documentation. Can I throw links right in the chat, or
You
can I
should
just
be
send
able
it
to,
to
yeah.
you? So like something like that. It's just a cheat sheet that you can Google. So we'd be looking for. We know we want to move
Nice.
execution there. We don't specifically know much about assembly. We're assuming. So we look at conditionals and jumps. So we look down towards the bottom. We see jump, and then in asterisk and reg, it says unconditional absolute jump. Arg is a register. Cool. Well, we already know ESP is a register, so we could do something. We could jump to ESP. So now we have to go see if we have a jump ESP in the application.
Oh, interesting. And
ESP points to the top of the stack. It's the extended stack point.
Now, actually, I actually have a question about that. So when we're jumping to a register, you know,
Hmm.
are we pointing to essentially it's a pointer, right? Or we're pointing to an
Yeah,
address that's stored in the register.
yeah. So
Okay,
it's not gonna jump to wherever EAX or ESP is in memory. It's gonna jump to the memory, what's in there.
right. Okay.
So if we have, because if you remember, the ESP had an address in it, and that address pointed to our C's. So jump ESP is going to jump to that address and start execution on those C's, which is what we would like to have happen.
And if you like me avoided systems programming because you started with Python and went to web, this is why pointers actually matter.
Yeah,
Because you're a lot of times when you get down to the assembly, what is stored in memory is a reference to another spot in memory. Even if the first spot in memory is a register, right? It's pointing to someplace else. So pointers really matter. Are you talking about the thing, or are you talking about the thing that it's referencing?
yeah, and you'll once you start developing your own shellcode and stuff like that, and the Win32 APIs, you're going to run into pointers quite a bit.
Yeah. Okay, so we want to look for jump ESP somewhere in the disassembly.
Yeah, so let's restart the program. Uh, yeah.
I'm doing the point and click just so folks can see it. Okay, and
We'll just let it execute and then Control F to find.
okay, and Control F to find. Do I have to be in the disassembly window? Yes.
Yeah.
Okay, jump ESP.
Yep.
Oh, dope, right there.
Perfect. So we have an address. Now, did Mona come with this? So
Did Mona come with us? That's a great
yeah.
question.
So for this particular binary, I can put some links into it in the chat after, or we can talk about it. I don't know if Mona comes pre-installed with Immunity. Uh,
I don't think so,
ASLR,
but I'm wondering. No, because it didn't come with Flare either, so that might be
yeah.
something we'll have to set up.
So we can set that up, but we can also just talk about it. So ASLR or address space layout randomization might be an issue if this binary used it because that address would be different every time. Uh, ASLR is not enabled in this binary, so we can hard code memory address.
Um, is there a Windows equivalent of checksec that we can use to like get that kind of information about the binary?
There is, and I don't exactly know what it is. Been in Linux land for a little while.
Yeah.
Does anyone in chat know right off the top of their head?
Just right click and go to properties.
Oh, okay, yeah,
On the executable, will it actually tell us?
cool.
Or go to process hacker? Yeah, that was going to be.
Yeah.
I don't even know where I would look for this. Details. Yeah, like they ain't gonna tell me about that.
Well, we can just run through installing Mona pretty quick. I think all you need to do is just drop the Python script in Community's Python modules folder.
Okay. All right. So I've never installed Mono before. I know what it is, but I haven't actually done that. So let's walk through that.
Yeah, gotcha. Okay, so I will put a link in the chat, and I will also not promise that this works.
That's okay. That's oh man. Here we go.
So mona.py is the Python file you're going to want.
Alrighty. Okay.
Here, I'm just going to boot up my VM real quick because I have it in there. I'm pretty sure it's in the Unity file, which is the program files, Unity, and I think there's a Python modules or there's Python commands. It's one of those two.
It's so funny to use invoke web request for something legitimate and not to download payloads.
Yeah, I mean, is that even actually ever used legitimately?
Okay, it's total tangent, but I actually have a legitimate question. Is there a non-malicious use case for alternate data streams? I cannot think of one.
Sketchy stuff.
Other than I guess to indicate, the signature of the web. That's about it.
Yeah, I didn't get to spend much time as a Windows sysadmin, so I wouldn't be able to tell you.
When I learned about that, I was like, okay, what was that meeting even like? It's like, okay, I have this great idea. We're going to allow people to create files that hide other files. What are alternate data streams? Neon, great question. So basically, Windows has this capability of splitting the personality of a file, and meaning that your file pointer actually can reference two separate streams of data. They're within the same file, but like the default stream is what you'll usually get, but you can also specifically add to a secondary data stream inside that same file. And by using certain tools that know how to extract that data, you can get that out of it as well. So think of it as like intentional steganography inside of Windows files.
Yeah,
Totally
it's
insane.
I don't get it. Yeah, so it is the Pi commands folder community, so it should be under like program files x86, community inc, community debugger, Pi commands.
So I just tossed the mona.py in there.
Yeah, you should be able to. You might have
Cool.
to restart Mono, or you might have to restart Immunity. But
All right, so let's see. Program files, Immunity Inc., Immunity Debugger. Can you access the alternate data streams in a URI? No, I don't believe you can, Sar, unless you're leading me again and in which case, please tell us. But generally speaking, I use streams.exe, which comes from sysinternals to get at it. There's some other tools. You can also, I think there are some PowerShell commandlets that'll do it as well. Um, Actually, I know for sure there are. Get content has a stream flag. Okay, mono.py dropped in. How will I know if it's there? Plugins. Let's restart Immunity and not guess.
I am muted. Sorry about that.
Okay. And okay. So we
Yeah, we can.
have Mona theoretically is loaded.
Yeah, so let's run it first.
All right. So how we're gonna do that? It's like
Uh
exclamation
oh,
point.
I just mean the application,
Oh, got you.
and that would be exclamation mark Mona
Yeah.
space modules.
Cool.
Hey, there we go. So you would be able to check out the defenses the specific binary has with this. So you'll be able to tell, if it's got ASLR, and
Very
it'll,
very cool.
yeah.
I'm super curious now, just to compare some tools. Oh, love it. Okay, so Cutter has a nice little dashboard that can also give you some information. So, for
Okay.
example, here it tells us that it's a PE, that it's 32 bits, read and execute, and NX bit, static false, relro, NA. So, I think that means. I reloc's true. The Relro NA, is that ASLR or is that something else?
Uh, I am not sure.
Relocation read only. No,
Yeah, it's
not quite.
relocation read only.
Okay. Thank you. Sorry, yes. Okay, so it doesn't actually tell us. What I'd be looking for is a PIE, right? But it's
Yeah.
not listed here. Okay. So Mona tells us.
So if we zoom in, we'll be looking for specifically the brain pan executable, and it will tell us probably false across the board. Yeah.
Ah, there we go. So ASLR is false for
Yep.
brainpan.exe.
So we can use anything in brainpan.exe and yes.
Cool. Let's back that up. We've been talking a little bit about ASLR. What is ASLR?
So it's address space layout randomization. So it's a way to basically make this stuff harder. Uh, all of the memory addresses in an ASLR binary will be different uh, at different times. So if we hard coded a memory address, it might work in this specific exploit, but if we reboot the machine, it'll probably be different.
Exactly. Put another way. So when your computer, when your operating system loads a program into memory, right? It has to set up what's known as a virtual memory space to make all that stuff happen. And there are some defaults about the way the binary is set up to allocate that space. And the problem is that if you're doing something like what we're trying to do here, and we're going after, addresses in memory, and we can guess them because we've debugged it and found out how this thing is laid out. If it's the same every time, and we have no way of leaking, or if it's the same every time, we're able to then make an exploit that goes to specific memory addresses that works every time. Address space layout randomization says, no, 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 no. We're going to move different chunks of this program around in the virtual memory space so that you can't guess where things are going to be when this thing runs. Now, it's not perfect. ASLR does have its limitations because it is chunked in that way. So there are some limitations to it. And if there is another vulnerability where you can leak memory addresses, that's one way that you can maybe get around that. But yeah, so when you come up against, it's really important for learning this stuff too, because if you're trying to do some of these exploits, especially on Linux, and you're on a machine that has address space layout randomization turned on and you don't know it, you will be pulling your hair out trying to figure out why the thing that looked so easy in the tutorial doesn't actually work on your machine.
Yeah, exactly.
I know that from personal experience.
Yeah, I've done that too. So we know that that's there. We know that ASLR is off. We know where jump ESP memory location is. So now we can code it into our exploit and see if we can direct code execution there.
All right. So what happened to our UI, by the way? Because whenever this
Oh,
happens, right? We've made some massive change to our user interface with Mona. So what happens, and how do we get back to where we thought we needed to be?
gotcha. So the bar up at the top, hit C.
Hit C. Cool. That's that's some great UI design there. Immunity.
Yeah.
Nice work. Okay. So our objective is, let's talk a little bit more about what we're trying to do with our jump ESP command
Yeah.
and opcode.
So we can get up to our EIP. Yeah. Immunity like a bunch of masochists. Yeah. I've moved. It's what I was taught during the OSCP and stuff like. But yeah, so we can overwrite EIP, and we know we're going to have room on the stack to write some stuff. So we want to move execution from like to the stack so that we can execute the bytes that we write to the application. So EIP is a pointer, so we would put the memory address to a jump ESP instruction, and hopefully, fingers crossed, the CPU will read that, and then run the instruction, and then jump execution to the stack pointer.
Oh, that's super clever. So what's the difference between doing that and doing something like a NOP sled to wherever you want to go, just like loading it up into the stack and pointing
Uh,
it to, like, using the instruction pointer to point that to somewhere in the NOPs, and then it'll slide down to where your shellcode begins.
yeah. we could do that, but we know that regardless of where the memory addresses are located, yeah, even though ASLR is disabled, uh, our stuff's going to be right on the stack.
Okay. I really like that. I've actually, this new to me. The first thing that I would think to do is just like fill up the stack and then use nops to make
Yeah,
sure that I get to where I want to go. But since we have a jump ESP, we can be even more elegant than that. That's really neat.
yeah, and we're still going to use an upside, to be
Okay,
perfectly honest.
got it. All right. So to recap, the plan is, look, we now know that we can fill up this stack with whatever we want, right? And we can also then control the instruction pointer to move around in that space. Actually move around throughout the entire program, but since we control all the stack space and we can throw code in there that we want it to execute, our plan is to fill up the stack with not just garbage, but also, by the way, our payload. Um, but in addition, we're going to then change the instruction pointer to this opcode that we saw that makes the program jump to the current stack pointer. What that means is that by jumping to the stack pointer, it'll take us to the top of our payload basically, and then start executing the code that we want. Sound about right?
Yep.
Rad. Um, all right, how do we begin?
Okay, so we need to go find the address for jump ESP and instruction.
Okay. There's one of them, although that's really high up. I thought we had another one that was. Uh, oh, we're in NTDLL. That doesn't seem right.
Oh, yeah, we can just hit the M button on the bar.
There we go. There we go.
There we go. Yeah.
Okay. That's closer to what I thought it was. So we're gonna copy the this address right here, and so I'm gonna keep using interactive Python as kind of my notebook.
Yeah, for sure.
Um, and your mileage may vary. I find this to be kind of a really nice way of doing it, but and actually context dot archivals. Oh, it is set to x86 by default. So what I've done here is I've set the jump ESP to this. Actually, what I should do is change it to, instead of, let me put this another way. We're loading bytes into the stack, right? But this jump ESP, I've saved it as a hex value. It's actually just a number according to Python. But I want the bytes, probably. So
Yeah, so I think Pwn Tools has a specific function. To be perfectly honest, I usually just ending this and inserting hex into registers manually. So I've never used P32, but I think that handles it for you.
it does.
Yeah.
So what this will do, pack 32, is it takes into account little ND or whatever NDNS you set. By default, it's going to be little, and gives you back the bytes uh, for that. Now, they can't all be printed correctly. Yeah, sorry, saying P32 is a
Yeah.
shortcut for struct.pack with the weird struct symbols. That's absolutely right. Um, but yeah, so we have these bytes saved. Okay, cool. So
Oh, sorry. I was gonna say. So the next thing we want to do, create a new payload, and then
mhm,
we want to go set a breakpoint in the debugger on the jump ESP memory location, and then we'll run it again, and hopefully our execution will stop to indicate that we've hit that breakpoint. Uh, so we've successfully overflowed into EIP, and then EIP is ready to do that instruction.
okay, so yeah, I think at this is the point where we're really getting into um like beyond just tossing text at a terminal, right? Actually building out an X
Yeah.
build script. I think that's where we are. Um, do I have? I do. Delicious. All right, so I'm just installing Pwn Tools just to make things easy here in my Windows environment. Could not install packages. Oh, because of course not. Um, Run as administrator. I'm doing that which I consider unholy, which is using Windows as a development environment.
Yeah, I it happens sometimes.
Yeah, needs must. Okay, let's go ahead and make a new file here, and we'll save it. I'm just going to save it to download so it's in someplace easy to get at. Um, Python.
It definitely does, Sarsec. That is for sure.
So something I learned, sort of related, not really, but something I learned recently is that one of the things that Windows uses to determine whether it needs to kick off the user account control dialog to elevate your privileges is if you name something setup, install, or there's a third word that it uses. Setup, install, maybe update.
Really?
And if you make that part literally part of the file name of an executable and you launch it, it'll be like, do I need UAC? I think I do. That's one of the things it uses to determine that. So if Windows is doing that, like, why isn't it looking for things like exploit.py?
Wow. Things get scarier every time you look behind the curtain, I guess.
Honestly, one of the most alarming things I've ever done was read the Windows internals textbook.
Yeah, I gotta get around to that someday.
The second volume just came out. Okay, so this is great though. Now I get to pretend that I'm John Hammond, except that he uses Sublime Text. Um, and I'm gonna do so payload equals. Aren't there? Zarsek asks, aren't there some antivirus programs that just scan certain sequences of bytes of known malware? Zar, you're describing Yara, and that's
Yeah,
kind of like what you got. Yes,
that's
Yara signatures, even when they strings or bytes, so that's pretty much like what it is. Yes,
yep,
and Sarsek, the other thing you're talking about is like the ICAR signature, which you use to test a lot of the antivirus stuff that is specifically looking for that signature to test if it works. Yep.
yeah. False positives then are super fun because then you end up starting to literally look at the bytes of a program, why it might be setting off a rule that is completely.
So the overflow length we know is 524, so we're going to store that. So the payload we're going to start. Well, let's see. Jump ESP. We'll save that as well. Equals P32. Do, 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 do. I had
That's
that
a
in a
really
movie.
good question.
Um, so what happens if I paste that sequence of byte in Twitch chat? It depends on if your client is storing it or not. People do that all the time, by the way. Um, I can tell you for sure that if you put it in Teams, something will make noise. I guarantee you that that's true.
It is definitely true. I can confirm.
Okay, so I got the address back, at least amongst other things. So P32, yeah, let's get the rest of that out of there. 0x. Okay, so we have the jump ESP instruction encoded correctly, and time to build our payload. So what do you think? Do we want to just start by um, overflowing and seeing if we can get to the instruction pointer or the jump to the stack pointer? And
Yeah,
okay,
so that's what we should do is we're gonna take our 2000 byte payload, 524 A's. Um, our jump ESP, and then I would like to do instead of C's, we should do slash X for breakpoints, or like one and then one breakpoint and then whatever. It's a manual breakpoint, so we can hit our breakpoint, and then we can hit F7 to see if execution will, if the next instruction will be on the stack, which should be a breakpoint.
Okay, so jump ESP plus. Walk me through that again.
It would be slash XCC.
Okay.
Cool. And then just our the rest of our payload, which would be a bunch of C's.
Okay.
Yes, there's like I definitely skip the C step and just send like thousands of breakpoints usually.
Okay. So to make this work the way that we kind of want, we're going to. I'm going to use Pwn tools to maximum effect here, which is we're going to do connect 127.0.0.1 and 9999 is our port
Yep.
because this thing is running. Then we're going to do con.receive 2048, just get those bytes out. And actually, I want to print that out to confirm that it's actually happening. And then con.sendLine our payload and see what happens. Why not remote? It's the same thing, Sarzek. It's just syntax trigger. I think it's the exact same function that gets called underneath. Okay.
Yeah, it looks good.
So, um,
Yeah, I've never used Pwn tools before, so
oh, fun. Uh, do I seriously? I was like, why don't I have? Yeah, I was like, where's Pylance? Why am I not getting yelled at for things? There we go. We don't need the Python extension, but I just set up this Flare VM machine today, so I have all sorts of. Okay, so without it though, if I do python.exe exploit.py,
are we running the executable, or are we paused somewhere?
uh-oh.
Oh, there we go.
Oh, times. Oh, this is actually kind of funny. Uh, there's a PEMDAS problem.
Yeah, yeah.
Nope, that's wrong. There we go. Could not connect. Is it running? It's paused, of course.
It's paused. Yeah.
Okay, but hey, we're not getting the same errors. That's always good news. Hey!
There we go.
Okay, so before we look at the immunity debugger, we're hoping that we hit the breakpoint for the this address, right? Our instruction pointer should be looking like this.
Yeah.
Okay. On the
Yes. So
money.
we did hit the execution. So if you press F7
Okay.
for single step, yeah.
Okay.
So we hit our int3 command. So we know that we're now on the stack. If you want to hit F7 again, access violation. Yeah. So we have to disable DEP.
Okay. What is debt?
So it's data execution prevention. So it's the operating system not allowing some data structures and memory locations to just be executable, like the stack,
Hmm.
because of things like this.
Okay.
So is this on a VM or
Yes, this is
is
on a
this in a
VM.
VM? Perfect. One second. Let me just find the command. I have it written down somewhere.
Yeah, so as I was talking about, once you start using pwn tools, you'll never go back. Yeah, except there are a couple of things like one part I actually don't love yet is the way that it does ROP chains. I find that API super funky. And I actually prefer to manually build out the ROP payload myself still, just because I don't like all the I feel like the way that it goes looking for gadgets and then builds that out a little bit auto magical for my taste. But that being said, I've never built really super complex exploits, so I'm sure that once that happens, I will be more than
Yeah,
happy to use easy mode.
yeah. I've really enjoyed staying manual, but now I'm working through Rob Emporium and doing some other stuff. Uh, and I can see how some automation would be awesome.
uh, is that verbatim? Do I just do curlies with current?
Yeah, so that's going to be your current boot profile.
Got it. What? Is
Uh, CMD.
not in PowerShell?
I don't think so.
Ready? Oh, right. If it's expansion like that, that's probably why. Boo. Oh, secure boot is on.
Oh,
Well,
I've
poop. I can fix that problem. I just have to turn the VM off. We definitely need to turn that off, right?
yeah.
Okay.
You won't be able to execute from the stack without it.
Right.
Yeah. So Sarsec, I think that might be a little bit.
Build a
Uh,
full ROP chain.
yeah.
That'd be wild. I guess I mean
It'd be a
we
lot
want
of
to
fun, but
yeah. Let's do the basics first. Okay, so good. Now this has become a lesson on Hyper-V. And by the way, turning off secure boot is something that you're going to have to do if you ever want to run Linux machines successfully on Hyper-V anyway. Um, so that's fine. All right. So here's my Hyper-V window, and I'm going to need to configure this thing to not have secure boot. So I just basically turn this off. Um, and I don't have a TPM or anything installed, so it should not scream at me. It should just boot right back up and not care. Although the word should is doing a lot of work in that sentence. Uh, oh, we have a question from Scissor. What is your day job like? Ginger, you answer first, and then I'll take.
so my day job, it really depends on the day. So I work in a very small cybersecurity team. So some days I'll be doing penetration tests and vulnerability assessments, and some days I'll be full out blue team, or some days I'm stuck in dreaded meetings all day.
That sounds extraordinarily similar to what I would say. Yes.
Yeah,
Nominally, my job is security analyst. I work for UCLA Health, so I, it's actually kind of cool. I have a very large sandbox to play in. We're talking about definitely tens of thousands of systems that we're dealing with on any given day, all sorts of different environments, medical devices, things like that. It's super super fun, and uh, yes, like nominally vulnerability management is the top of the job description, but because I brought some offensive skills to the table, yeah, it's a little bit more purple teamy on a day-to-day
yeah,
basis, spending a lot of time doing web application pen tests, threat hunting. as well as adversary emulation, which I love, and clowning on vendors, which is always good.
Oh boy. Yeah. You know, I I don't even think I can count the number of times someone has tried to sell me some AI product in a box.
We have a bingo card, right?
Yeah.
For any pitch meeting
Buzzword
where,
bingo.
oh yeah,
Yeah.
next generation,
Yeah.
machine learning, AI.
Yeah. I do the same thing, but it's usually we're pretty small, so it's there's only usually one at a time.
Yeah, it's interesting. I've only this is the first time I've ever really worked in a major organization. You know,
Hmm.
I used to run the technology for schools of like 300 students, 100 faculty. So, not super big. It was small enough that I could sometimes get away with SneakerNet, like if I needed to do an update across faculty machines, I'd, go with my flash drive if I had to. That is not an option here. So like the way that I think the biggest thing that I had to adjust to was the change management process. It's no joke.
Yeah.
It's not whenever I feel like it. It's no, there's a committee. You have to send it to review. People have to sign off on it. There has to be a record.
Yeah. It's like I have some scans scheduled next month, and next month is the soonest I could do it. So I
Yeah.
know exactly what you mean.
Yeah, that's another one too. Scheduling web app tests, right? Where we're like, hey, um, first of all, you hope that you have a development environment to work with, but maybe not. And
Yeah.
if not, it's like, hey, is there a backup of this somewhere?
Yeah, man. Hunting down development environments to do testing in. Sometimes they don't live very long.
No. Here's one that I'm running into now, which is kind of interesting, is we're doing a lot of API testing,
Hmm.
which is its own kind of like subspecies of web app pen testing, assuming it's a REST API or an HTTP based API. And I have to insist sometimes, and I don't really blame the developers for this, but it's just like a new thing for them. Which is like, hey, the shape of your data in the test API has to match what's in the real one. If you just have like empty objects in there, then I can't test it
Yeah.
because I won't know if I hit something. Fitness First Bahrain, thank you so much for the follow. All right, we've vamped sufficiently and we're back in. We can
Sweet.
fire this back up.
So we should try to disable dep again.
Oh, right, 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 right.
Yep.
So that was bcd edit exe slash set current nx always off.
Awesome. So we'll have to reboot,
Done deal.
but
Oh, right. Okay. So we're not done vamping then.
no,
What's your
no.
perfect Sunday?
My perfect well, uh, fishing.
Really?
Like rod and reel. Oh yeah, man. I live in a small town near a lake, so like fishing.
So that's is that on a boat or is it from the shore?
Uh, on a boat. I have gone out in the canoe a couple times with. Yeah, it is wonderful. I
God,
caught my first
yes.
salmon not long ago.
Wow. Kudos.
But yeah, so it's mostly from the shore, but I have gone out in a canoe a couple times. I've been on a fishing boat, but I don't make boat money just yet.
Well, the trick is to charter. Well, like one of the things that I wanted to do, like, and I started thinking about this about a month before we went into lockdown here, was like, I should learn how to sail. Um, and you might not think about it, but actually the sailing in LA kind of rules because you have very, very predictable winds from offshore. And
Oh yeah.
and you have the Channel Islands, which are pretty close. And so you have like Catalina, which is like a day's sail away, and then you can anchor there and just weekend there, and it's a killer place to go hiking. Some really good bars there. It's a really, really nice place to do a quick vacation. And then you have the other Channel Islands, Santa Cruz, Santa Rosa, and Anacapa Island, and they're like backcountry hiking. So if you want to do that, you have those accessible as well. Plus, like crazy good scuba diving.
Yeah, I've never sailed. I've never scuba dived, but I do spend a lot of time around the water.
Man, you're making me miss autumn even more than I already was.
Yeah.
Emreza, thank you so much for the follow. I have no idea if I pronounced that correctly, but it's good enough for me. Yeah, I'm originally from Philadelphia, and
Oh, gotcha.
living out here has messed with my brain.
So you're from the side and you're on the other side. Gotcha.
Yes, yes, I am definitely a coastal elite of one sort or another. I have opinions about the middle of the country.
Yeah.
All right, one more time. Well, we've got so ASLR is disabled, so we can fire up immunity.
Yep. So without depth, we should see because we had an access violation before we tried to run that breakpoint that we set manually. This time we should be able to hit it,
Cool.
and that will prove that we can run code off the stack. And then all we have to do is put a payload on the stack. And I think we probably want to use something like SF Venom or something instead of trying to write something.
Oh, so yes, yes, and what's a payload? Great question, Czar. Um, so
So, oh,
go ahead.
sorry. I was gonna say in this case the payload is going to be a bunch of bytes. Uh, that is, it's just code. We're gonna send code directly to the CPU, and it's gonna do whatever we design for the payload. We're probably gonna do reverse shell because I think that's what we need to do for try hack me.
Hmm.
But it could be anything. I've made payloads that cut input to the system and play Bon Jovi songs. So you can do kind of whatever you want.
Incredible. Uh, what Bon Jovi song?
It's an 8-bit rendition of what's that one? Shot Through the Heart.
Hell yeah.
Uh, I
All
forget the
right.
name of that.
I it's not shot through the heart.
It's You Give Love a Bad Name, isn't it?
It might be, yeah.
Yeah, I had a lot of fun making that one. That was that was a good time.
That's like that's the way cooler version of a thing I did once to my students where for Halloween, this was in the bad old days where remote desktop was a C2 framework for Apple.
Yep.
Sarsec, I'm not playing it because I don't want to get a copyright violation on my channel. But so yeah, remote desktop used to be basically just like if you had an admin account across all the machines you could remote to, you could run arbitrary commands on it. It was gorgeous. And for Halloween, I used an Apple script to download and play without any UI interaction. So the laptops just started doing this. Um, the Christopher Lee, the guy who played Saruman,
Yep.
his rendition of Edgar Allan Poe's The Raven started coming out of every single student laptop at the same time.
That's pretty sweet.
Once upon a midnight dreary. Okay, so this thing's running. We have that's really nice. So immunity saves your breakpoints even if you close it and open it back up.
Yeah.
Good to know. Sarsek, it would be abuse of power, except I got the teacher's permission before I did it. So it was consensual abuse of power. The kids didn't
Abuse,
agree to it. That's true.
yeah, abuse of power with permission, I think.
That's just use of power, I think. Okay, so we have our payload here, and we're going to basically try to fire this off again, but hopefully get to whatever's on the stack. Yeah? Which
Yeah,
is
so we
nothing but
should.
A's and C's, but
Yeah, so the C's are on the stack. So what we're going to happen is we're going to hit the breakpoint of our jump ESP instruction because that's what EIP will be pointing to. But the issue we ran into last time when we tried to run the instruction X C or the CC, which is the breakpoint, we got an access violation because DEP was enabled. We weren't allowed to run off the stack.
okay.
So hopefully this time we'll hit a breakpoint, and then when we hit F7, we'll hit another. We'll get an access violation.
All right, fingers crossed. Let's fire this off. Okay. Bunch of A's, bunch of C's. We're
Yep.
at the instruction. We've got the right instruction pointer. So F7, we want to step forward. Okay.
Cool. So we're there. Let's hit it again. And just keep hitting it for a couple times and see if we can access. So we got no access violation. So we can start crafting a payload to put where our C's are.
And just to be,
And
yeah, and just to be super explicit, so like, look at this. You're looking at this in the disassembly, right? We're looking at this in the assembly. Yup. And it says that the opcode is increment EBX,
yeah,
but that's not really what happened, right? What we hit was our C's, but because they're encoded as 43, the disassembly is reading that as this opcode, but that's not really what we wrote. We just wrote 43.
yeah. So that actually will increase EBX. So if you watch
Yeah, yeah,
EBX, it should keep going up. If you keep hitting F7, it
yeah.
should.
Watch.
Yeah.
If you watch EBX right over here, it will keep going up.
So whatever we put in that space now is going to execute. So now all we need to
Awesome.
do is just send it something it can execute.
Okay, and what are we going to send it?
Let's do an MSF or shell.
So cut out a little bit there. I think you were saying we're going to do an MSF Venom run
Oh, reverse shell payload.
or the reverse shell payload.
Yeah.
Okay, love it.
So I don't know. I'm
Well, I've got
I'm
my Kali
assuming.
machine up here, so so we'll do this. MSF Venom. Actually, did this thing expire on me? Incredibly, it did not. Uh, so we're gonna do MSF Venom, but the payload is going to be Windows.
Windows. Yep.
Now, the Meterpreter unstaged. How we have to be careful about how much space we actually have to work with here, right?
Yeah. So let's just go for the Windows x64. Do you prefer Meterpreter or do you?
Meterpreter's big, and we don't really need it for this, right? So I
Yeah.
think we'll just go with I what the generic reverse or CMD reverse TCP.
Just shell underscore reverse underscore TCP. I think is the stage one.
Let's so this actually is something good. Windows shell reverse TCP. Thanks, Husky. If you wanted
Yeah.
to check it out, this is something that I do pretty commonly, which is list payloads and then grep to Windows and then grep to reverse just to
Yep.
see um, what I have available. Now, while we're on the subject of shellcode, I mean, this is good, and we will use exactly Windows to try PowerShell reverse shell. That's going to get
So
big. Is
we're
it,
gonna want
oh, just the straight up
underscore.
x86, right?
So I think your machine is 64-bit, but yeah, we can use x86.
Uh,
X86 should
let's
be
keep it the
fine.
same architecture just to remove questions, assuming that the size is okay.
Uh, I've actually never tried this. The application itself is running 32-bit, so I don't when we throw.
The process is
Yeah.
32. Yeah, fair enough. So let's do Windows shell reverse TCP. Yeah.
Yeah, that's the one.
Okay. So we're going to do that and MSF enum. That's our payload. The format, what are we going to make here?
So the format's going to be Python because we're writing a Python script. The next is going to be dash, yeah, our out. Uh, we don't need to declare an out file because I think we're just going to copy and
From the
paste
terminal?
this
Yeah.
into, yeah. Dash B. So we didn't talk about doing bad bytes, and I don't know if you want to or not tonight. But normally, uh, you would send the entire ASCII range and the entire extended ASCII range to see if any bytes were filtered out or
Mm-hmm.
breaks the application and stuff like that. Generally, what I try to do is get up to this point and do it, and then I'll include dash B. So I'll do a null byte, a line feed, and a carriage return. So that's
Do you comma separate them? You do, right?
uh, no, you don't need it.
No? Okay.
And
Uh,
zero D.
yep.
And
Okay.
that's just because I know that those will generally break, a string going over.
Yeah. Okay. Um,
And then we just need to set our L host and L port parameters, which are local or listening, however.
yeah, in this case, we will do 127.0.0.1, but when we go to fire this off against the BrainPan server, we will change that to our listening machine on the VPN.
Yeah.
And L port, let's do quad eights. Um, and I actually am going to do an out file here just because the copy pasta with tmux might get weird.
Gotcha. Yeah.
What did I do wrong? Invalid argument. Do I put it in quotes?
I think you do. Yeah.
351 bytes. That should fit, right?
Yeah.
Okay. Oh, actually, right. Then
But yeah, so our payload is only 300.
yes.
So that's all we'll have to copy into the application. And I think we used 528 so far of the 2000 that we have left over.
Yes. And then file explorer. I actually don't know if this is going to work. If I can go from VM to VM with the clipboard. Oh yeah, that's one reason I actually like Hyper-V. The clipboard integration is rock solid.
Well, I take it back for poking fun at Hyper-V earlier.
Okay, so in our file browser here, oh, open folder, yeah, downloads. Open that, please. Thank you, VS Code. That was very helpful.
Yeah.
Yeah, we're almost there.
And then all we gotta do is escalate privileges on the box.
Is that all? He, why would this happen? Okay, that was annoying. Let's try to do that again. Okay, yes, I trust the authors. Okay, so here's our exploit.py and there's our mt.py. Love it. Okay,
Right.
so here's our bytes. This is the shell code. Now, while I was going to mention this before, while we're on the topic of shell code, shell storm, yes, is another place to get shellcode. Although, yeah, mostly it's got Nix like stuff, but it does have some Windows shellcode available here to like fire off and execute PowerShell. Really neat to see. all the different shellcode samples. And one of the reasons I do like Shellstorm is very often some of the like built-in stuff, especially in Pwn tools, doesn't work the way that you want it to. Whereas I have uh, much better results with this stuff. And also, if you are size constrained in any sense, this does give you like, look at this. Here's a shellcode for binsh that's 8 bytes. So if you really need something that's super, super, super tiny, you can find it in Shellstorm. Toss that in there. Okay, so we have our shellcode, and we need to incorporate this into our exploit. So in terms of where this, so our A's are overflowing the buffer, right? Then we
Yep.
have our jump to the stack pointer. And we're pretty much going to put the actual shellcode after that. Is that right?
Yeah. So we could keep our CC there so that we know we hit it.
Mm-hmm.
So if you ever like lose the breakpoint on your jump ESP, it would still be there. So we could put our payload in between those two commands.
And we're going to just, for ease, we're going to do buff, replace payload here. And
You'll
just
want
take,
everything but the first line.
yep. Boom. All right, so we're adding our shellcode directly after the manual breakpoint here. Oh, it looks like there's another one that we might hit. That's interesting.
That could be part of a greater instruction.
Okay. Um, and then so after that, do we just add what do we just fill it out with anything that's left with C's
Yeah.
or okay.
Yep. That would help us keep. Yeah. That's what I think. So the one thing I would recommend is using a knob just before the payload, just because I've had some personal experience with interpreter or Metasploit payloads
You say a null byte?
where we're going to do a knob sled. So we're going to want to
Oh.
do this at the top
Oh,
of our
interesting.
stack, just to give our shellcode some room, just in case, which we don't know much about, requires some room above it to move stuff around.
You have to add nops to align the stack. So
Yeah.
do we know how many we're gonna need, or are we
Throw 100 on. You
toss
could throw
100?
100 on there.
Okay.
Yeah, it should work.
Okay. And the reason this is just an opcode in hex that you kind of learn
Yeah.
quickly, which is that 0x90 is the no operation instruction in x86 assembly. So basically, it says do nothing. Um, Nothing to see here. Move on to the next instruction. And so what we're doing basically, the idea of a NOP sled is you set up this chain of don't do anythings just to make sure that the instructions that you're trying to get to are where you eventually arrive.
Yeah.
Okay, so we have our NOPs, we have our shellcode, we are padding it out at the end with any space that is left over. And what we will need, I believe, is let me fire up the
Should
Windows
have
terminal here. We're going to need to set up the listener on port 8888. Cat NBP. Cool. All right, so are we missing anything or are we ready to go?
we should be ready to go. We just have to
Let's
reset.
restart the executable. Okay, run. It's been a minute, so for new viewers, we're gonna shout out Gingerroot's own channel. He was kind enough to come on here for us, but he has his own channel, and watch that space for some cool stuff coming up.
Yeah, thank you.
Yeah, no problem. Okay, so this is running. We're ready to fire the payload. Fingers crossed.
Okay.
Okay, we hit our SP.
That's a really good sign.
Okay. And do we want to do F7 or just continue?
Let's do F7 just to make sure everything looks okay.
Okay. Look, there's our CC. And
Yep.
then here comes a bunch of knobs.
Cool. We can just hit F9 and go check our listener.
Okay, there's F9. I thought I hit F9, but we're still on this knob. Uh, there we go. And
I think we did it.
I think we did.
Sweet.
I don't have a flare, so, but yeah, I think we just got ourselves a reverse shell off of BrainPan. That is super cool. Okay, dang. So what we're gonna do now? Yeah, that's super impressive. L- let me just say, so like, I I am learning this along with y'all. I have actually never successfully done a buffer overflow on a Windows executable, so this is the first time for me. And Ginger, you've done an awesome job explaining how all this works and how to use immunity. Um,
Yeah. Thank you.
so yeah, like I don't know why, but like I personally had like a mental block. 'Cause, like I'm so comfortable in Linux, I was like I don't know about doing this on Windows. I thought I was going to be fighting with a bunch of other stuff, but like this rules. And yeah, it's a lot more accessible than I thought it was going to be. So again, kudos to you. Let's end tonight by seeing if we can at least get the user flag on try hack me with
Yeah.
that listener.
Yeah, for sure. So we're gonna. Well, I mean, we already got a hint from Try Hack Me, so we kind of know that what we have to do. I think on the webpage it said Windows executable running on a Linux machine.
Is that right? So it's a Linux shell that we need to do.
Yeah. So we're
Okay,
gonna do just change out our payload for a Linux one.
got it. Okay, so at this point, what I'll do is I will again capitalize on my clipboard powers here. Thank you, Hyper-V, and copy the exploit from my Windows VM over to the Kali VM.
And we'll have to change the parameters, I think, for our
Exactly,
connection.
exactly. And fire this up in my lovely, lovely Vim. And we'll also change up our interpreter, right?
Yeah.
Our MSFN and payload. So here it is 10.13.7.20. You can tell you've done too much try hack me if you have your IP address memorized.
Yeah, I was pretty pleasantly surprised. I just started on Try Hack Me to find out that it's the same.
Wait, is it really? I didn't know that.
Always, yeah. Like I've been in it a couple of days now. I don't think it's changed.
Oh! I thought you meant it was like 13 to 7 to 20. I was like, that doesn't seem
No.
okay. Yes, it is. It stays. It's whatever its DHCP tool is. It's very aggressive about uh, keeping leases. So, uh, real excited about that. Do we need? This is a question. Do we need the bad bytes marker for a Linux binary?
Uh, do we need? Maybe not. It won't hurt.
It won't hurt. Okay, that's what I thought.
Yeah.
Especially the null byte.
Yeah. The null byte is usually it indicates termination of a string. So if there's a null payload, the application might not read the whole thing. The same thing with the line features return. What you're trying to avoid is the application on the other end being like, okay, that's everything.
Right. Yeah, it's our good point. If the binary is the same, it probably should. The filtering is usually in the
Yeah.
application logic, not really depend on the OS. Yeah, good call. Good call. And especially if it's running. Oh, okay, no, because it is. Got it. Okay, so we're gonna change this to
Yeah. And we just
Linux x86. Uh,
I think it's just still shell underscore underscore TCP.
I think you're right. I think there is an I
In
keep wanting to
x86,
write I keep wanting to write it. Um, but no, I think you're right. It's just shell versus TCP. Uh,
it might be an 86.
D155. I'm sure that's lead speak, but I can't parse it right now. But D15540R. Thank you so much for the follow. Desayer? Whatever. I appreciate your follow, even if I can't pronounce your name. Invalid
Oh,
payload.
okay. It would be x86 then. Yeah.
What's B&B game do? Uh, at the moment, Czar nothing because we're gonna play that next month. I gotta remove that. I gotta remove that perk. Okay, so now I get to do this in Vim. That's exciting. So same deal. And let's get back over here. We're gonna get rid of our payload as written and replace it with our new payload. By the way, if you don't know what we're doing with this awesome text editor, there's a video a while back on Vim that you can check out that we did. And we did a whole evening on Vim. You can check it out on the YouTube channel. Look for Hack Summer 21. There's a whole Linux series, and Vim was one of those videos. Okay.
You need to change the address it's connected to.
Yes, we do. Seriously? Okay, that was annoying. There we go. Look good?
Yeah.
Okay. Are we gonna get messed up by the CC?
Uh, it's not any debugger, so it shouldn't actually run, but we can get rid of it now that I think about it. Yeah, sorry.
That's okay. Just I don't know if it was gonna mess up anything. Okay. Let's set up the listener. The XCC is a NOP if it's not running a debugger. Okay, good to know.
Yeah, that's what I was thinking. Cool.
Yo. We have remote code execution.
Yeah, we did
Nice.
it. So I think the user flag.
Let's see if we can get a proper shell going.
I wonder if there is a penetration testing blog that has had as many hits as that RockNot blog for for upgrading the shells.
I know, right? Uh, okay, so we're in home puck.
Oh right, I don't think there's flags for this one. I just click on the button up there.
Oh, there
Yeah.
isn't. Oh well, now that I know it's a Linux machine, I mean, geez, how long does it take to root this?
What would be the first thing you would check for
Uh,
Expo?
I want to run sudo -l just to see if there's anything.
Yeah.
Okay. So there's a non-C util. And what does a non-C util do?
So yeah, you can
Manual
do.
command? Are you kidding me?
Yeah. Well, no. Oh,
I'm
it's expecting manual as the thing.
oh manual. Then just bin bash. Oh wait a second. I messed something up there.
But yeah, it is GTFO or
Okay, fun. All right, I'll play with this later, but this was good. Uh, wow. Okay, so to recap, we were able to debug using Immunity Debugger, um, and figure out how to overflow the buffer, control the instruction pointer on our brainpan.exe, create shellcode that uh, made a Windows reverse shell, and actually we were able to then translate it into a Linux reverse shell. All starting from understanding how to read what's going on not only in the stack but in the registers using Immunity. So, Ginger, thank you so much. This was fantastic. Would you be game to come back and do another one of these another time?
yeah, for sure,
Awesome.
absolutely.
Uh, well, thank you so much, everyone here. Once again, give Ginger Root a follow on his channel, and
Yeah, thank you very much for having me, everyone.
yeah, our pleasure, absolutely. And so I think we're gonna call it a night for this one. But let's see if there's anybody else streaming right now. If you're not familiar with the hack list, get familiar with the hack list. We are Legion, and there we are. Um, oh, awesome! You know what? GoPro is streaming right now, and I think I owe him a raid. So we're gonna raid GoPro. But Ginger, thank you again so much for hanging out with us tonight. Really appreciate it. This was a lot of fun, and I learned a lot. I'm sure everyone else watching did as well.
Yeah, thanks again for having me. This was a blast.
Everyone else watching did as well. All right, so
Yeah, thanks
if
again for having me. This was a blast.
everyone else watching did as well. All right, so yeah, let's go to setting up a raid is weirdly difficult in Streamlabs, so let's go to right there. All right, so friends, until next time, be good to yourselves, be good to each other, and happy hacking, everybody.